Yeah, start.
Okay then. Yeah. So Sanath, you can start, and
So,
once our slides comes for the intro, we can give it up, and you can give your start with your introduction.
I have that slide.
Yeah,
I'll
sure. Then let's start.
sure. So, hello everyone. Welcome to 41st Bangalore Virtual MuleSoft Meetup. So, today's topic is getting started with Async API. It's still in beta version, so let's see what MuleSoft has to offer in this segment. So, first of all, I would like to thank everyone who joined here. I know few of you are joining in the middle of work, so thank you for making time and joining this presentation. So, this shows the enthusiasm that we all have for learning. So this recording, whatever the meetup we are doing, this will be available on the meetup page after within 24 hours. So if you want to refer it later, you can always access. And in between, if you have any questions, feel free to turn on the mic and ask the questions or use the chat box. And at the end, don't forget to give us the feedback. So it will help us get better and deliver better. So yeah, so I would like to thank Bangalore meetup leaders for organizing this meetup. Sam, Nitish, Pranav, Abhishek, Vandana, and Jyoti. Thank you for organizing this. So, last but not least, let me introduce myself. I'm Sanakumar MP. So, I started my career in MuleSoft back in 2021 with Accenture. Currently, I'm working as associate technical consultant at Salesforce, and I have 3+ years of experience in MuleSoft and 3x certified in MuleSoft. So, this is a quick intro about me. So, without further delay, let's get started. Uh, So agenda for today's meet is what is Async API and what MuleSoft has for in this segment. What is the product roadmap looks like? What are the features planned in future for this Async API? And let's look at Async API specification, the components of it. And at the end, we'll have a small use case and a demo and the benefits of Async API in MuleSoft. And we'll have Q&A session at the end. And if you have any questions in between, feel free to ask those in the chat box or turn on the mic and you can free to ask questions. So first of all, what is Async API? So it's an open source tool that helps us document and describe the event-driven architecture. So it's similar to RAML, what we have for REST APIs, but it has an extra features for handling evented architectures. So here, there are few things that Async API can do. So first one is define an interface. So any developers, architects, or product managers can use Async API to define an interfaces. Define an interface. This follows design first approach. So usually when we have event-driven architectures, we didn't had any specification to write. So we always used to jump in, start the development work first. So here we are starting with we have a Async API specification. So we can define the specification first, present it to the customers, get the approval. Then once design is ready, then we can go for the implementation. So this will reduce the back and forth work between development and testing. Develop first, then test, and then find bugs, come back, develop again. So that will be avoided. And then we can create machine readable documents. So Async API document can be used to generate the codes. We have scaffolding support in Studio and ACB as well. So with the specification, we can scaffold the initial flows and we can validate the messages. We can apply API manager policies and we can generate documentations as well. And it supports a wide variety of messaging protocols like AMQP, Anypoint MQ, Kafka, Solis. It supports platform events and many more message brokers. So next up is a release of event-driven support on Anypoint platform. I mean, many of us here we know what is event-driven architecture is. So if any of you who don't know what is event-driven architecture is, let me simplify it as I explain. So consider we have Salesforce as a data source. So it's generating thousands of messages or even millions of records uh, in some of the cases. So these message could be account update or invoice request, which eventually need to be sent to multiple downstream systems. So event brokers or messaging queues sits in between source and the consumer. So this is how we can asynchronously design uh, our requirements. So with this upcoming release, MuleSoft enables customer to power real-time communications across their enterprise with support of end-to-end integrations of evented applications. So with this, what organizations can do is can easily create real-time architectures to ensure customer experience on a single platform. So we can have all our RAML implementations, evented architecture implementation, and a single place, single anypoint platform exchange. And we can build reusable event-driven services while adhering to industry standards with support of Async API specifications. And organizations can also drive adoption of real-time applications across enterprise by enabling events in any point exchange. So once we publish into exchange, right? So these specifications will be discoverable across the organization. Let's say if teams are working in 3 or 4 different scrums, so whatever developed in Scrum 1 will not be the other Scrum team might not know what is being built. And since we have API specification published in Exchange, it is discoverable across the organization. If people can, architects can look at it, and if they can reuse some of the components, so that will they can use that. It will boost the reusability as well. So next up, we have a product roadmap, the design governance catalog of AsyncAPI 2.6 went GA on last June. And along with that, in the June itself, there is a support of open beta for implementation is also released. So in the open beta version, we can implement AsyncAPI. AsyncAPI supports implementation for Kafka and Anypoint MQ. So this is the supported systems in beta version. So next we have a GA coming in October version. So that will include support for Solis, PubSub, as well as Salesforce platform events. So this will be released in next month. And in upcoming in 2025 February, there will be a support released for Async API 3.0 version as well. So Async API 3.0, this is the latest Async API version available in the market. So this is the small product roadmap for this Async API. And implementation, we can implement the specification in Studio as well as ACB. So the support is given in both the tools. So next, that's about the product roadmap and the features that are planned for future. And coming to Async API specification. So let's see what are all the components or different parts that Async API has. So first one is the ID. So it's kind of a unique ID for the specification that you give. And then we have info box. So this is this is where we can define the metadata for your specification, like the titles, the author information, the reference to external documentations, etc. And then we have servers block. Servers block will have here we can define the connection for the connection details for the server. For example, we have different brokers. For example, in beta version, it supports Kafka and Anypoint MQ. So all the connection details and the protocols, everything can be defined in the servers block. And next up, we have channels. So these channels we can consider like the resource types and RAMLs. So here we can define the operations, the publish, subscribe operations, the summary, the payload part. We can define the how the payload should be, headers. So all this information can be defined in channels. So as I mentioned, this you can consider it as a resource type that we have in RAMLs. And we have tags. We can give tags to group the specifications, and we can give reference to external docs. And next, we have a important segment called components. So this is where we define the reusable components inside the specification. This is like a fragments that we have for REST APIs. So, but we can't publish them separately, like what we do in fragments. It's like we publish them separately to exchange and use it inside our RAML specification. But here, the components will be inside the same specification. But we can group the reusable components in that. So it will include schemas, payload schemas, the security schemas, messages, parameters, correlation IDs, trades, etc. So I'll show you all these components once we while doing the demo. So next, I have come up with a simple use case to demonstrate how we can make use of Async API. So before this, if you guys have any questions or anything, we can take that. Not, I'll proceed with the use case. And I'll take that as a no. So let's proceed. So this is a small use case that I've implemented order processing system. So let's consider there is a web page, so where user is placing the orders. So this is related to order processing. So on the web page, if user is placing the order, let's consider web page is doing some validations and then posting the request to MuleSoft API. So here we are following asynchronous design. So once the MuleSoft API request receives the request, it will immediately publish the message to any point in queue called queue name is order placed. And once the message is published, it can respond back to web application, say message received or something like that. It's a synchronous approach. So message will be processed afterwards. So from the order placed queue, MuleSoft API again consumes the message, and now it performs the inventory check. So if product is available in the inventory, so it can again publish the message to order confirmed queue. So if during inventory check, let's consider the product is not in stock, but it's available for back order. Back order in the sense we can consider like let's say it's currently not available in stock, but it can be fulfilled within a day or two. It's like it's maybe in transport or maybe in production. So it can be fulfilled 1 or 2 days later. So in this case, there will be a different logic. They can connect back to customers and uh, you know provide a notification. If they're okay with back order, they can book that. So for this use case, let's say the backorder implementation is not within MuleSoft landscape. It's in let's say it's implemented in some other integration technology. So that is consuming a message from Kafka topic, let's say. So in this case, when MuleSoft API performs inventory check, if product is not available in stock but available for a backorder, so the message will be published to Kafka topic. And the third case is if a product is not in stock as well as it's not available for back order also. So in that case, the order has to be cancelled. So message will be published to order cancelled queue. And again, MuleSoft API can consume that and notify the user. And if product is available, it will be published to order confirm queue, and MuleSoft API can consume that and update the inventory and fulfill the order and notify the user. So this is the simple use case that I've come up with. So now let's see the specification API, Async API specification and the code for this. Is my screen visible? Right, I'm sharing platform page. Yeah.
Visible.
So yeah. So let's look at the specification first. Okay. Login. So yeah, this is the Async API specification version 2.6 that I've developed for the use case. So here, let's see. I've explained the components of Async API before. So let's see how we can define this inside a specification. So here it starts with Async API tag and the version details and info. As I mentioned before, here we define the metadata of a specification, so title, versions, descriptions, contact information, etc. And default content type is application JSON. So this is uh, like a data type for the payloads, what we mentioned in RAML. And tags, this is the group API specifications. And here we have servers. Servers in the sense the different brokers and their connection details. So here I've defined two. As I mentioned in the use case, we are using Anypoint MQ and Kafka servers. So here, whatever the details we give, the most important thing is the protocol. So we have protocols for each message broker. So we have to use that. So for Anypoint MQ, it's Anypoint MQ. For Kafka, it's Kafka. It's mostly similar. For each broker, it will be different. And using this, when we implement the Async API, so using the details, whatever we provide here, so it will create the connection configurations. Basically, the global elements will be created, will be scaffolded in Studio based on the details we provide here. So here we can use dummy URL, so you can provide actual URLs also. So once it is scaffolded, we can change. So that should not be an issue. So next we have channels. As I mentioned, it's like what we define resource path in RAML. So here I have four different channels for this use case. First one is order placed. So where as soon as the web application make a request, so the message will be published to this one. So here I'm providing the bindings. These are all parts of Async API specification. So you can explore separately. Async API specification, it has a lot of components. It has a lot of capabilities. So that is a huge topic itself. So you can explore what Async API has all the different components. So here I've used all the things that is required in to implementing those. So here we defining the bindings and for order placed. So I'm using Anypoint MQ. So that's why I'm defining the destination and destination type for Anypoint MQ. The queue name is order placed and it's of type queue. And server I'm using for this order placed is AMQ server, and AMQ server I have defined here with the protocol Anypoint MQ. So here we can define operations, how we define post, get, put, and RAML. So here in evented applications, we have two operations, subscribe and publish. So for publish, so these are all just operation IDs, description, summary you can provide. And the message is like a body structure. So that is expected to publish to this queue. So for this, as I mentioned, for the reusable things, we have to use the components uh, segment, components element in Async API. So here I've implemented it. It's at the end. So in the components, I'm defining the messages. So have the message defined for four different operations that we have seen in the use case. So first one is order placed. For the order placed, I have defined the schema here. Schema is like a what we define data type. So we enforce some constraint on the payload, right? So that's we can do in Async API using schemas. So schemas, I have it in a separate folders. So this is the schema for order placed. So it's a schema version and title. The type is object. It includes properties like order ID, string, customer name, string, email is a string, and we have items. Items will have products. So it's of type array, and each item will have each item is an object of product ID, product name, quantity, and price. So this is basically like a data type. So this is the schema I have defined for that. And similarly, we have different schemas for order confirmed, order ID, email, and the product information for order cancelled, order ID, email, and the reason, and for back order, order ID and email. So we can define the required fields like this. So this is how we can define the reusable uh, things in under components. So going back to order placed publish operations, so that's how I enforce the payload validation here using components and the schema. And for subscribe, again it will be of same time order placed. So next we have order placed channel. So this is again any point MQ. The queue name is order cancelled and it's of type queue, and server is any point MQ. So for publishing, again, it's a similar approach what we followed for order placed. So I've defined the payload schema for that. Subscribe will also have same order cancelled schema. And next operation channel we have is order confirmed. Order confirmed also it's any point MQ. Queue name is order confirmed and it's of type queue. So next we have a backorder. As I mentioned, let's in this use case, the backorder is implemented in some other landscape. It's not implemented in MuleSoft technology. So here what we have to do is only one operation we have to do, that is publish. So for publishing, I've defined again the payload structure and under components using schema. So yeah, so this is how specification, Async API specification looks like. And based on this, again, we have a simple documentation generated here. And I have published this on Exchange. We can publish. Exchange. I've already published it to Exchange also. So let me show you. So this is the one. So since it's available in Exchange, it's accessible across the organization. So any architects, anyone from different teams, they can access and see what are all already implemented, and if they want to reuse some of the components, they can reuse. So here it also generates a simple documentation here based on what are the specifications that we have defined. And one thing I want to highlight here is we have different types, right? When we publish RAML, it's REST API. We have a different type for custom policies. So likewise, we have a type for Async API, that is Async API. So this is the type. So this is how a specification looks like once we publish it to Exchange. So let's look at the code now, how we can implement this. Let me share Studio. So yeah, before going to this, let me show you how it scaffolds the specification from Exchange. So let me name it as let me import the specification from Exchange. Yeah, so this is the specification. So we scaffold. So yeah, so the application is scaffolded. A basic template is created from the specification what we have defined. So here we have the flows created for different queues that we have defined, and along with the listeners, corresponding listeners. So let me show you the Mule palette first. So API kit for Async API. So this is the components that is released, and currently it has two operations. One is message listener and publish. So we had defined two brokers, right? One is Kafka and another one is AnyPoint MQ. So you might be wondering, so where that is defined here. So let me show you that. So in the scaffolding part itself, as I mentioned, so it scaffolded the connection details as well based on the details that we provided in the server block in the specification. So for Kafka, so it has already created the configuration. So here in Kafka, we have only consumer configuration. So we don't have there is other configuration called producer. So that we don't have. Only one operation we have defined, and related to that, it has generated only one one Kafka configuration. So you can see here that is connecting to backorder topic. So this is the topic name. And next we have any point MQ configuration also scaffolded here. So since we had given dummy URL in the specification, it just taken that and client ID and client secrets that is already referring from the properties file. And this is the configuration for API kit for Async API. So here we can see. So currently it supports only two message brokers, Kafka and Anypoint MQ, and you can see both of them are configured since I defined in the API specification. And as I mentioned, in October we have the GA coming out for this Async API implementation. So in that, it supports Solis, PubSub, as well as Salesforce platform events. So this is how it's linking. So here, this is the server key, what we have defined, if you remember from the specification file, Kafka server, and the corresponding connection configuration. So this is the connection configuration. It is generated and it's updated. And if you want to change the naming convention, like different organizations follow different naming conventions. So this is just a scaffolded from Studio. So if you want to change the connection configuration names, make sure you change it here as well. So it should be correspondingly changed here. There is no option to select. You have to provide the connection configuration name directly. Same for the Anypoint MQ configuration. So this is the global elements part, and how it is connecting to different message brokers. For example, it's order placed. So this is connecting to this queue is on Anypoint platform, Anypoint MQ. So here we have option to configure the server. So we have two server, Anypoint MQ server, AMQ server, and Kafka server. So whatever the server ID I configure here, the message will be published to corresponding message broker. So here it is configured as AMQ server. So whatever the listener is there, it is currently listening the events from Anypoint MQ. And backorder. So this is a Kafka topic. So here server ID configured here is Kafka server. So this will listen the events from Kafka topic. So this is how the scaffolding works. So let me show you the application that I've built for the demo. So similarly, we have the Kafka configurations defined here, Anypoint MQ configuration defined. I've already configured it to connect to Anypoint MQ and Kafka. I'm running it in local just to show for the demo purpose. And coming to the flow. So here, if you, as I mentioned in the use case, the user is placing the order on a web application. So in that case, we need a REST API endpoint exposed to receive that request from web app. So that's why I have a listener defined, which is going to listen to that. This is exposed to receive the order information. Once it is received, so we are publishing it to queue. It's a Anypoint MQ. So the server selector is AMQ server and the channel name is order placed. So if I want to publish a topic, I'll change the server name and change the topic name. That's it. That's how easy it is. And before Async API, how we used to do it, like if I want to publish something to any point MQ. So, and if my customer wants a payload validation before publishing, so probably we used to have a schema validation before publishing, validate the payload separately, verify that everything is proper. Then we used to publish. So since we are defining the specification and we have a support for Async API, API kit router, so that we don't have to do now. Since we have defined the specification, it will automatically validate whether the payload is in proper structure or not. So if it is in the proper structure, then only it will be published. Otherwise, you will receive an error. So I'll show you that once I run this. And for the inventory, so I have an CSV file in my local system, so that I'm considering as inventory. So that's about that the information. And okay, once for we had four different operations. First one is order placed. So for order placed, a web application will send a request to this endpoint, and it will be published to this endpoint MQ. And once it is placed, from order placed, again we are consuming the message. The listener is listening to that queue, and as soon as we consume the message from order placed, we have to perform inventory check. So after the inventory check, I can have a choice router to validate whether item is in stock. If item is available in stock, I'm going to publish it to order confirmed queue. And second check is whether it is eligible for back order. If it is not available in stock, next check is whether it's eligible for back order. So if it is available for back order, I'm going to publish. This is the publish connector. So I'm going to publish it to since it's a back order, the implementation is in different landscape. So I'll be publishing it to Kafka server. The topic name is back order. And the last option, if it is out of stock and it's not eligible for back order, the order should be cancelled. So for that case, the message is published to AMQ, anypoint MQ order cancelled queue. So next, again, we have a listener on order cancelled queue, which is going to consume the message and set up the notification part and notify the user. So for notification, just for simplification purpose, I'm not using any email or anything, just have a logger just to show how this use case works. So it will just log the payload that we are preparing for notification. And next, for the order confirmation, uh, the API will consume the message from queue and it will perform the inventory update. Let's say if I ordered in the inventory 5 items were there, if I ordered one out of it, so it will update the inventory, prepare the notification, send the notification to customer. So this is the use case that I've implemented. So let me run it. So I've implemented it on Studio. So as you guys are aware, it takes good amount of time to deploy. So within that time, if you guys have any questions or anything, you can take up.
I can say like one answer is there a minimum mule runtime version requirement? So I think max.
4.6 plus. 4.6 plus. 4.4 is not supported.
Okay, fine. And where we can define queue and topic, I think you have covered it, right?
Yeah, in the specification, we have a server block.
Okay.
So we
Maybe you can
can
take it
define,
one more time.
yeah, sure. By the time it deploys, let me share my, go back to specification. So hope it's visible.
Yep.
So yeah, here we have a block called servers. So where we can define connection details to different brokers. So here I have AnyPoint MQ, which is defined as AMQ server and Kafka server. And the name of the topics or queues we can define in channels. So I have order placed channel. So in that I have a bindings. And since for order placed, it's an AnyPoint MQ, I'm using that protocol. And destination is order placed. That's the queue name. And destination type is queue. Similarly, for topic, for Kafka topic. So yeah, this is the one. For bindings, Kafka topic is order backward and partition we can give count. So I have one partition defined. And so this is how we define the queue and topic names in the bindings.
Thank you. Another question is API manager manages these async APIs as well.
No, no. Because API manager comes into picture where you are exposing your REST APIs and it's used by multiple clients. So you are defining some policies, some authentications there. So here the majorly the application is interacting with message brokers, queues. So publish, subscribe with the queues. So
Okay.
mostly there is no external vendors or anyone hitting an API. There is no such concept, right? So that's why we don't have a API manager instance for this.
So hope Ranjit, Sanat has answered you. If there is any question, yeah, anyone has, and they can
Yeah.
ask in the chat or unmute yourself.
So let me go back to Studio. Hope it's deployed. So yeah, it is deployed and all the flows are connected. So let me clear the logs. So let's start with the negative scenario first, where we check whether it's validating message or not. So this is the payload I defined. So for this, I've defined schema also in the specification. All this message order ID, customer name, email, and items. So these are required ones. Let me remove order ID from here and try to just send this, publish this into a topic.
I
Into
think we cannot see the postman or the payload which you are talking about. It's still the
okay,
studio.
sorry. Let me check. So yeah, so this is okay. So this is the API is deployed. So this is the port it's listening on, and this is the data. I mean data type or the payload that I've defined in the specification: order ID, customer, email, item. So all these are required items. So first we'll test the negative scenario. What I'll do is I'll take out the order ID and let's see how it uh, how the validation works. So I'll just trigger this. Okay, see it. The error message is received. Message contains content does not conform to schema from spec. Required key is order ID. So this is the message it shows. Let me share my studio. So here you can see. So it started. You can see the start logger, the payload. There is no order ID in this, and this is the message error it threw API kit validation error. So yeah, as I mentioned before Async API support. So to do this, if you're directly publishing it to AnyPoint MQ, we have to have a external explicit schema validation or something to validate uh, payload is in proper structure. But since we're defining specification, it's inbuilt now. So let me trigger a valid payload now from Postman. Uh, so let me trigger another request. I give the wrong quantity. So yeah, I'll expand for logs. So this is the starting logger. This is the payload that I've triggered with. Order ID is 12345, customer name is Danny, and product ID is this PRD 9876, and the product name is TV. Quantity that I'm ordering is one, and price is this. And for inventory, I'm using a CSV file. So in that file, I have for this product PRD 9876, I have 5 quantities available in stock. So here, what I'm requesting for is one quantity. I'm trying to book TV of one quantity. So once this is the starting logger, order received, and then here this is the just acknowledgement back to Postman that order request is published. And once it is published, immediately we have a listener listening to events on order placed queue. So here you can see order processing started. Maybe I'll show you the code along with this. So this is the end logger that was in order request published. And then we have a listener listening to order placed, and you can see start logger is order processing started. So that's what we have here. Order processing started. So this is the order request, and it performed the inventory check. And here we can see the log. Inventory check completed. So yeah, it is available in stock. Available in stock. True. So in that case, since the order is available, so it goes to the first router. Inventory dot stock details dot available stock. So this is resolving it to true. So the message will be published to order confirm queue. So here you can see that product stock is product available in stock. Details published to order confirm queue, and order processing completed. So this completed this flow, listening on order placed. So once the message is published to order confirm queue. So again we have another listener which is listening to order confirmation. What it is doing is, so it is updating the inventory, and then it is sending a notification in the sense, in this current code I'm just printing it in the log. Let's see how it processed. So here you can see order processing process confirmation started. Order confirmation processing started, and then inventory updated and notification sent. So this is the notification. Order ID email subject. Order ID is order. This is the order ID 12345 is confirmed. Email is, we are pleased to inform to let you know that your order XXX is confirmed. Thank you for shopping with us. And order confirmation processing completed. So this is the one happy part. User placed a order on web application. It reached MuleSoft. It performed inventory check. Product was available. Then it updated the inventory, and order is fulfilled. So next we'll see how backorder works. Let me trigger. As I said, in the inventory, I had before giving this demo, I had 5 TVs available. Now let me request for uh, 6 TVs. I'm from Postman. I'm sending a request with the quantity as 6 TVs. Let me trigger that. And in the inventory, we have for back order, we have only five items available. I mean, up to 5 TVs I can back order. That is eligible for back order. More than 5, back order cannot be fulfilled. Let me trigger it again. So now to test the back order, as I said, back order limit is 5, and the current available stock is 4, and I'm requesting for 5. So it should go to, as per the logic defined, it should go to back order. So let's see. So order is received, order request received, and it's published to order placed queue. Again, there is a listener listening to events on order placed queue. It consumed, it performed the inventory check, and this time it's currently 5 TVs are not available in stock, but back order is eligible. So that is you can see back order is eligible for this product. So here we can see. So it's not available in stock. Second choice, it's available for back order. So it is what it is doing is it is publishing it into Kafka topic. So here we can see product eligible for back order and details published to back order queue and order processing completed. So let me show you. I have a Kafka deck here. Let me show you that. So hope it's visible. Let me expand this. So this is a KA deck. I've installed Kafka in my local. So let me show you the published message here in topic. So here you can see there are messages available. This is the one I published recently. Order ID. Let me expand. I think it's visible. Yeah. Order ID is 123 Email is tan@gmail.com. So the message is now published to Kafka topic. And as I mentioned, for back order, it's implemented in different landscape. They can consume the message and fulfill the back order. So please bear with me. I have to share the studio back. I'm using the monitor. So if I share the studio with monitor, it will not be visible clearly. So let me reshare studio. So yeah, so we have tested the back order. So here we can see how back order logic is working. Sorry, I stopped it mistakenly. Deploy. So next, let's see how cancellation works. So for that, since I have only now I have 4 TVs available in stock, and 5 TVs are eligible for back order. But from Postman, I'll send a request for 10 TVs. So this request should be cancelled. So let's wait for it to deploy. I think one of the subscriber is failed. Let's see. I'm sending the request with 10 TVs. So this request should be rejected. I think the listener which failed is from order cancellation, I guess. Let me redeploy. One of the listener uh, couldn't get initialized. Let me redeploy this.
Just a reminder, we have 5 minutes left in 9:30.
It's fine. I'll wrap it up. But it's a last scenario. Anyways,
And we have few questions also there.
yeah, it's fun. I can take those. 5-10 minutes should not be an issue. I'll take this. No problem. So yeah, whatever the request I published before, so it consumed and processed now. So if you remember before this deployment, I published a message with 10 TV requests, and it got published since the uh, cancellation, the listener which is listening to order cancellation couldn't initialize, so it didn't process last time. So since I redeployed the application, it again fetched the message available on the queue. So here we can see order processing started, and this is the payload I sent with 10 quantity and order available in stock. Let me check the stock, how much I have the number. A second, I'll check the Excel file. Oh, okay. I'm updating the Excel sheet, the inventory data with just 4 TVs available. It had more number. I just updated the inventory. Let me trigger a request now. 10 TVs. Oh, this. So yeah, so here we received a new order request with 6 TVs, quantity as 6, available in stock is 4, and it's published the request order placed, and the order processing is also started, and it checked the inventory, and once inventory check is performed, it's identified that the product is out of stock. So in that case, product is out of stock and details published order cancellation queue. And again, the listener which is listening on order cancellation, it started, consume the message, and it sent out a notification to the user. So this is the one we regret to inform you, to let you know that your order 12345 is cancelled. The reason the item TV is out of stock. So yeah, this is how the cancellation works. So this is the demo part. Let me go back to presentation. So I just have one more slide to cover the completed demo. So I'm already mentioned the benefits while explaining of Async API support in MuleSoft. First is design-driven approach. So here we are going to implement we are going to design the specification first. So based on the customer requirements, we can design first, present the specification what we defined, and confirm that's the proper requirement. Then we can go for implementation. So this avoids a lot of back and forth uh, design and testing efforts. I mean, if we just directly start implementing, so we code first, then go to testing, identify the bugs, come back, fix it. So that takes a lot of time, right? That's how currently it is working. So with the support of Async API, we can define the specification, then get it approved, then we go for design, then we go for implementation, and design and catalog API speak for evented channels. So once we have the design, we can publish it to Exchange where it is accessible throughout the organization, and it helps reusability as well. And it's a one control panel for REST and evented APIs. So all the REST specifications, evented specifications, all are under one roof, Anypoint API Exchange, and it gives unified design experience across all the specification. Supports we earlier we had only for REST, now it supports Async API. We can write with Async API, we can write specification for evented architecture as well. So and then unified lifecycle management, version controlling, and monitoring. So these are the benefits that uh, that MuleSoft is giving with the Async API support. So yeah, so that's it for this topic. If we have any questions, we can take those now.
Maybe you can quickly go to the chat and you can answer.
Can we use any other messaging solutions beside AnyPoint MQ and Kafka? So whatever I demoed, it's a beta version. Beta version supports only Kafka and AnyPoint MQ, and there is GA getting released next month, October, and in GA it supports two more, uh, Solace PubSub and Salesforce platform. Uh, what is that? Salesforce. Uh, I forgot that platform events, Salesforce platform events. So these four will be supported from next month, and in future releases, the it will no MuleSoft will release support for further event brokers. They can't support everything at once, right? So this is newly released. So one by one they'll keep on adding it. So is it possible to get the POC? Um, I'll try. It's in my company laptop. Not sure if I can share it. Maybe I can prepare separate link. I can provide it to you. You can contact me on LinkedIn.
Maybe if you can share the, you can push the like into some GitHub repo, and so that we
Yeah,
can
yeah,
share
sure.
all the
Yeah,
attendees. You can share with me. Maybe I will
yeah,
share the later.
sure.
Yeah.
And then are the needed connectors included? Yes, that's what it's a scaffolding is supported, right? So based on the servers I define in the specification, it will add the dependencies automatically. Which type of server is supported? You are here. You are using Anypoint MQ and Kafka. Which are the types of server they supported? Server in the sense for using Anypoint MQ, the protocol we have to define in the server is Anypoint MQ, and for Kafka, it's a Kafka all in lowercase. So that's the protocol we define. And as of now, they mentioned, I think someone answered it. If we don't have an API manager, how can we secure these APIs? Yeah, Anusha, as I mentioned before, so these are event based. So we are subscribing the message from queue and we are publishing the message to queue. There is no third party interaction here. So for example, if we have a REST application, we are exposing it to multiple customers. They'll be consuming this. So they have to authenticate, or you want to enforce some of the additional policies on your API if you are exposing it to outside customers. But here it's mostly the communication is between uh, the queue and the application, the event broker and the application. That's it. So as I used in this demo, I used HTTP listener to receive the events and publish into uh, queue. So for that listener, it's again a REST implementation. You can enforce whatever the policy you want on the REST. But for these communication between message broker and Mule app, it's not required, right? So that's why we don't have API manager instance. I think I covered right most of the questions.
Yes.
Minimal
If
time.
anyone has any other question, and you can
Any
ask.
questions?
Yeah.
So if no
Thank
questions,
you.
we can wrap up.
Yeah. Thank you, Sanat. It was a great session.
Yeah. Thank you for organizing all the
Yeah. Yeah.
meetup leaders.
And make sure like all the attendees like share the feedback so that I can share with Sanat also.
Yeah. Do share the feedback.
Yeah.
See you guys next time. Maybe I'll come up with more topics.
Yes. Say slide I will upload into the meetup recording page. And recording I
Yeah.
will also upload there.
Yeah.
And POC code it depends on Sanat. If he will share,
Yeah.
then I will. Yeah.
Sure. I'll build one on my personal laptop. I can provide.
Yeah. Then you can push it. Okay, fine then. Thank you
Sure,
all.
sure.
Sure. Then.